Good afternoon, everyone. Thank you for listening on my presentation, the evaluation of wave runoff predictions from parametric models on Trinidad beaches. What is wave runoff? So wave runoff is the landward extent of the water's edge and is measured vertically from the still water line. Why is it important? Why should we look at it? So maximum positions of wave runoff are used to evaluate properties such as susceptibility to erosion, help predict coastal flooding, storm surge, and tsunami effects. It is also used in effective design of coastal structures. For instance, it is used to estimate the percentage of overtopping waves. As such, the accurate prediction of wave runoff is important to coastal engineers and planners. Over the years, many parametric models have been designed using parameters that are relatively easy to measure, such as wave height, wavelength, wave period, and slope, as seen in these four commonly used empirical parameterizations of wave runoff. However, it has been acknowledged in the literature reviewed that a number of additional parameters have found to have an influence on wave runoff, such as friction, tidal elevations, wind, and even swash infiltration, though these are not commonly used in wave runoff models. So what is the research problem? In order to define a single predictor with a wide variety of conditions is difficult due to the complexity of the data collection in the source zone. As such, several equations are based on data collected on one or sometimes two beaches, with the exception of Stockton et al. With a total of 10 natural beaches. Now, there are other models that may be based on maybe as much as 3 or 4 beaches, but it's very few. In Stockton's research, he concluded that the performance of a predictor was directly related to the data set from which it was based. Additionally, most existing models are designed using data collected on North American and Australian beaches. And because wave conditions and bathymetry, which vary around the world, are not extensively understood on how they impact wave runoff, there lies some potential errors and limitations when used for operational forecasting on Trinidad beaches. So this brings us to the aim of this research, which is to assess the accuracy of the 4 previously mentioned empirical formulae to predict maximum wave runoff on Trinidad beaches. Research was conducted on 3 beaches, 2 on the east coast of Trinidad, Cocos Bay and Mayaro Bay, and 1 on the northeast coast, Grand River Bay. The primary data collection utilized traditional surveying technique to observe wave runoff positions along an identified cross-shore transect marked by 6 50-centimeter long PVC pipes driven into the beach face. Once the runoff positions were visually observed along this cross-shore transect, their vertical elevations were measured using the total station and prism method, reference to the WGS 1984 data, and later reduced to the still water line using the tidal elevations of the data collection during that period. Other parameters such as beach slope, wavelength, wave height, and tidal elevations were also measured for the purpose of this research. So 5 statistical parameters were applied to assess the performance of the previously mentioned equations to observed values of wave runoff collected on these 3 beaches. We looked at the Pearson correlation coefficients, the coefficients of determination, root mean squared error, bias to determine the absolute fit of each model to the data, and scatter index. So here we have a graph of the predicted wave runoff versus the observed wave runoff, where the black solid line represents where the predicted runoff values are equal to the observed runoff values. So that's our ideal scenario. So this would then follow that all data points that lie above that line would represent an over-prediction of wave runoff, and all points that lie under that line would represent an under-prediction of wave runoff. From this graph, we can see that generally that there's an over-prediction of wave runoff with few cases of underprediction, mostly coming from the Stockton et al. Model. What we can also see is that as the wave runner positions, their elevations increase, so too did the overprediction of wave runner. This may be accounted for by the omission of these other parameters that have an influence of wave runoff. For instance, if we take a look at swash infiltration, these models, unlike many other models, assume an impermeable beach, which is not quite the case. So if we were to assume that, if we were to say that as the swash lines travels further up the beach, covering a larger surface area, not taking into account permeability, we would then expect theoretically a greater overprediction of wave runoff. Other, other morphodynamic parameters, such as friction and wind, may also account, well, the omission of these parameters, may also account for the overprediction of wave runoff. Here we have a summary of the statistical parameters that we examined, and we see that generally there's a poor performance of these four models, seen by their low values of the coefficients of determination and the Pearson correlation coefficients. However, among these four models, we see that Stockton et al. Did perform the best, as expected, considering that he covered 10 natural beaches with a wide range of conditions with low root mean squared error and scattered index of 0.15. So to conclude, we observed values of wave runoff were compared to predicted measures of wave runoff by 4 existing empirical formulae. We did see that these four models did not perform very well, with generally an overprediction of wave runoff in all models for all study areas. The equation by Stockton et al. Did perform the best with root mean squared error and scatter index of 0.15. And I'd just like to also add that this part of my research really just laid the foundation for me to now look at how I can improve the prediction of wave runoff, not only generally, but more specifically on Trinidad beaches, by looking at introducing swash infiltration as a parameter in these models. So that brings us to the end of my presentation, and I will take any questions at this time.
Thank you, Ms. Brathwaite. Question: why is the R square value so low?
That is a really good question. I would have to assume that there isn't a good relationship between the predicted values and the observed values. As I mentioned, because of the omission of the other parameters that have an influence on wave runoff.
Okay. Other question: how will swash infiltration improve these models, in your opinion?
In my opinion, I think it would improve the models because it would give a better representation of the volume of the swash lines that travels up the beach, and it would lower the prediction values. Because as it stands now, these models assume an impermeable beach, and there's no loss of water, there's no loss of velocity, because we expect with infiltration, we have other processes taking place that will lower the velocity of the swash lines, as well as the volume, resulting in lower limits of wave runoff.
Okay. In the 4 empirical models considered, was there any major assumption that could not be met in your experimental work or site conditions?
Yes. So one of the possibilities for the difference in the results could be the methods they use to observe the wave runoff. So I use traditional surveying, and some would have used video monitoring techniques. Also, with respect to the wave conditions, I would have modeled my wave conditions from an offshore buoy, where they would have directly measured their offshore wave conditions. So those things may come into play with respect to the difference in results.
Okay. Question, is coastal pollution a hindrance to coastal engineering? If so, did you experience any challenges due to barriers such as possible coastal pollution that may hinder the formulae use?
I'm not quite sure I grasp the question, but let me try and answer. Um, yes, it may hinder research in terms of pollution on the beach. That would also affect our runner positions because if the beach face is polluted, you would now have that limiting the wave runner positions. Also, in terms of conducting research, you're gonna have to clear away the beach, and does that actually give a real representation of what the runner positions are? If generally year-round the beach is polluted. So it does affect the research. I hope that answered the question.
Yeah, that assumes solid waste.
Yes, that's
Right.
solid.
Okay. May I ask a question? On that, with respect to solid waste, we have a lot of sargassum now on our beaches.
Yes.
How would that affect our wave run-up?
So that is also a very good question. It affected me personally having to collect the data because the wave run-up was actually very limited because as the sargassum not only remained on the beach face, but it was just generally heavy in the swath zone. So after the waves broke, there wasn't much wave run-up or activity taking place in the swath zone. So it really affected conducting the research, and it would alter what the positions of wave run-up would be at that beach.
Okay. From your data presented, perhaps a non-linear curve fitting might be useful in your future work. Was this considered?
This was considered, and I at this preliminary stage, I was just following what the previous literature conducted for a fair comparison of the results.
Okay. That's the last question, probably. Are there any parameters that may account for unpredicted data, such as pollution, that can be integrated into existing formulae for wave run-up, similar to turbulent parameters in the Navier-Stokes equations?
I am not aware of any existing parameters from the literature that I reviewed that can be added.
Hmm. Okay, can I ask one question? One of the concerns you had was the low amount of research done on beaches, and the one that gave the best result was the one that undertook it on 10.
Yes.
You are undertaking it on 3. Would you fall into the same trap as the others who did their research on a low amount of beaches?
Well, it was only conducted on 3 for the comparison's sake. For my research moving forward, because I would really be looking on improving the prediction of wave run-up on Trinidad beaches, what I intend to do is to have the number of beaches will depend on the beaches that cover the general characteristics of our beaches. And we don't have much variation in that. So with respect to the prediction of on Trinidad beaches, no. Generally, yes, that would be one limitation. I would have to define the conditions under which this improved equation would best be used for.
Okay. Are there any more questions?
I think there is one more question from Dr. Bachu. A quick answer will be appreciated. Ms. Brathwaite, the question is, from your data presented, perhaps a nonlinear curve fitting might be useful in your future work. Was this considered?
Oh yes, I answered this previously.
Yeah, she answered that question.
Oh, sorry, I'm sorry. So there is another question coming from Dr. Townsend. Are you more concerned about Trinidad or the effect of swash zone?
If I am more concerned about
Trinidad, or the effect of the swash zone?
Generally, I'm more concerned about the effects of the swash zone, and I think that the research will lay the foundation for further research with respect to the swash zone when it comes to infiltration. But just a small part of my research would just really zone in on Trinidad beaches, just because I understand the limitations of the model not being very applicable worldwide. just because of the complexity of data collection.
Okay, thank you, Ms. Brathwaite. It was a great presentation and very informative.
Thank you.
And appreciate your time.